Hello students, today we will discuss about electromagnetic induction. Have you remembered Oester's experiment? Oester observed in his experiment that when a magnetic compass needle placed near a current carrying conductor shows deflection. Also he observed that the direction of deflection will reverse when the direction of current is reversed. The observations made by Oester shows that an electric current produces magnetic field. Electric current is due to moving charges, so we can say that moving charges produce magnetic field. Very obvious question comes into mind, that is the converse process is true? Michael Faraday answered this question in 1931 by demonstrating its converse effect, that is by producing electric current by magnetic field or by changing magnetic field. This process is known as electromagnetic induction. Now let us define what is electromagnetic induction. So electromagnetic induction is the process of generation of electric current by varying magnetic field. Now let us discuss about Faraday's observations. Faraday took the coil consist of large number of turns and connected galvanometer across it. Remember, there is no source of EMF connected to the coil, and he moved the magnet along the axis of the coil. He observed that when there is a relative motion between coil and magnet, galvanometer shows deflection, and the direction of deflection of galvanometer changed when the direction of magnet is changed. Suppose first he move the magnet towards the coil. If galvanometer shows the deflection in left side, then when he move the magnet away from the coil, galvanometer shows the deflection in right side. When the relative motion between magnet and coil ceases, the deflection of galvanometer also ceases, and the magnitude of deflection of galvanometer depends on the relative velocity of coil and magnet. Faraday explained these observations like when the magnet moved towards the coil, the magnetic flux linking with the coil increases. So magnetic flux linked with the coil changes, and hence the galvanometer shows deflection. It shows that when magnetic flux linked through the coil changes, an induced current is produced. The current produced in this process is known as induced current. Also, the EMF setup due to relative motion between coil and magnet is known as induced EMF. When the magnet moves away from the coil, like this, also magnetic flux linked with the coil changes, it is decreases, hence the galvanometer shows deflection in opposite direction. So in both the cases, the magnetic flux linked with the coil changes. Hence he conclude that when magnetic flux linked with the coil changes, the current will flow in the coil. This current is known as induced current, and the EMF setup in this process is known as induced EMF. Another experiment, Faraday placed two coils near to each other. One coil P is called primary coil, another coil S is called secondary coil. Primary coil is connected to the source of variable potential, and secondary coil connected to the galvanometer. When he increased the potential, he observed that the galvanometer gave the deflection. When he stopped to change the potential, the galvanometer deflection reduced to zero, and on decreasing the potential, he observed the deflection in the galvanometer again, but in opposite direction. He explained the observation as The current in the primary coil produces the magnetic field, and hence magnetic flux will be linked with the secondary coil. When the voltage in the primary coil is changed, the current in the primary coil changes, and therefore the magnetic flux linking through the secondary coil also changes, and the galvanometer gives deflection. When the current in the primary coil is kept constant, the magnetic flux linking through the secondary coil does not change, and the galvanometer deflection is zero. From both the experiments, it is clear that whenever the magnetic flux linking through the coil changes, the induced current flows. From his observations, Faraday formulated two laws of electromagnetic induction. First law gives the cause of electromagnetic induction, and second law measures the magnitude of induced EMF induced in the circuit. Now let us state Faraday's first law and second law of electromagnetic induction. First law: whenever the magnetic flux linking with a circuit changes, an induced EMF and consequently an induced current is induced in the circuit, which lasts only as long as the magnetic flux is changing in the circuit. Second law: the magnitude of the induced EMF set up in the circuit is equal to the rate at which magnetic flux linking with the circuit change. Let phi b be the magnetic flux linked with the circuit at any instant, then according to Faraday's second law, induced EMF E equals to d phi upon dt, rate of change of magnetic flux.